The orange looks simple. A bright orb, a leathery skin, 10 neat segments waiting inside. But what you are holding is a chemistry laboratory that took the plant kingdom roughly 20 million years to perfect. Every layer of this fruit, from the pitted, oil-rich peel to the juice-filled vesicles you bite into, is a defense system. A defense system that just happens to be one of the most efficient delivery vehicles for vitamin C, folate, and flavonoids ever produced by nature. In the next 7 minutes, we are going to take this orange apart, layer by layer, and reveal exactly what is happening inside it and inside you when you eat it. Cut an orange in half, and you see 3 distinct zones. The outer flavedo, that bright orange skin, is packed with essential oil glands and carotenoid pigments. The white spongy layer beneath it is the albedo, rich in pectin and bioflavonoids. And the interior is divided into segments called carpels, each one filled with hundreds of juice vesicles. Those vesicles are not just containers. Each one is a tiny pressurized capsule of vitamin C, citric acid, and dissolved sugars, engineered by the plant to be punctured exactly when a seed-dispersing animal bites down. The orange you eat is a chemical contract between plant and animal, and you are the animal. A single medium orange delivers between 70 and 90 milligrams of vitamin C, roughly an entire day of the recommended intake in one fruit. But the number is only half the story. The real question is, what does vitamin C actually do once it enters your bloodstream? 3 things simultaneously. First, it acts as a cofactor for the enzyme prolyl hydroxylase, which is required to build collagen, the scaffolding protein that holds your skin, blood vessels, tendons, and gums together. Without vitamin C, collagen synthesis collapses. That is literally what scurvy is. Second, vitamin C is one of the most powerful water-soluble antioxidants in the human body, neutralizing free radicals before they damage DNA and cell membranes. Third, it boosts the absorption of non-heme iron from plant foods by up to 3-fold, meaning the orange you eat with your breakfast is quietly upgrading every other plant on your plate.
Most people associate folate with pregnancy, and for good reason. It prevents neural tube defects in developing fetuses. But folate is critical for every cell in every body, every day. It is the cofactor your body uses to synthesize and repair DNA and to manufacture red blood cells. A medium orange contains about 40 micrograms of folate, roughly 10% of your daily requirement. The form found in oranges is naturally occurring, bound to a polyglutamate tail that your intestines slowly cleave off, releasing folate gradually rather than all at once. This slow-release delivery is one of the quiet advantages of getting folate from whole fruit rather than a pill. Now we reach the molecule almost no one talks about, Hesperidin. It lives in the white pith and the membranes between segments, the parts most people throw away. Hesperidin is a flavonol glycoside, and it has a very specific job inside your body. It strengthens the lining of your blood vessels. Clinical studies have shown that Hesperidin reduces capillary fragility, lowers blood pressure modestly, and improves endothelial function, the ability of your blood vessels to dilate and contract properly. It also has anti-inflammatory effects in the gut. The lesson is simple. When you eat an orange, do not strip away every shred of white pith. That bitter-tasting layer is where some of the most cardiovascular protective compounds in the entire fruit are concentrated. Oranges contain natural sugars, about 9 grams per medium fruit, mostly fructose, glucose, and sucrose. But here is the critical distinction. Whole oranges also contain about 3 grams of fiber, and that fiber fundamentally changes how the sugar is absorbed. The pectin in the albedo and the cellulose in the vesicle walls slow gastric emptying and blunt the glycemic response. This is why a whole orange has a glycemic index of around 43, squarely in the low range. Orange juice with the fiber stripped out jumps to 50 or higher. The fruit is not the juice. When you eat the whole orange, you are eating a slow-release sugar package buffered by fiber, vitamin C, and flavonoids. When you drink the juice, you are drinking sugar water with vitamin C added back. They are not the same food.
That deep orange color is not decorative. It comes from a family of pigments called carotenoids, primarily beta-cryptoxanthin and beta-carotene. Beta-cryptoxanthin is one of only 3 carotenoids your body can convert directly into vitamin A, which you need for vision, immune function, and skin cell turnover. Population studies have linked higher dietary intake of beta-cryptoxanthin to reduced risk of inflammatory joint conditions and certain cancers. The pigments concentrate in the flavedo and bleed into the juice vesicles as the fruit ripens. The deeper the orange, the higher the carotenoid load. Color, in the world of fruit, is information. So what do you actually get when you eat an orange? You get vitamin C, powering your immune cells and rebuilding your collagen. You get folate, driving DNA replication and red blood cell production. You get Hesperidin, protecting the lining of your blood vessels. You get fiber, buffering the natural sugars. You get carotenoids that convert into vitamin A, supporting your eyes and your skin. And you get all of this for about 62 calories. 1 fruit, 3 defense systems running at once. A piece of evolutionary engineering refined over 20 million years, sitting in your hand. Open it, reveal it, and eat it whole, pith and all.